Alright, so example 3, the 2014 UCF Knights scored these points in their 13 games. We're going to find the mean and standard deviation. Alright, so plug these values into your list in Desmos. Alright, and then if you use the same thing as the box and whiskers, the mean's calculated in there too. So our mean, our x bar, is 28.8. Alright, so if you go through this, so we need, in order to figure out the standard deviation, we have to first do the x minus the mean, and then that answer squared. So for 24, it's going to be 24 minus 28.8, which equals negative 4.8. Okay, and then you square that answer to give you the next column, which would be 23.04. Alright, and that's how we get all these values here. So I'm just going to write the rest of the work down. So the x minus the mean for all these. Uh-oh, I got a typo here somewhere. There we go. 31 is 2.2, 53 is 24.2. Okay, and then you just take this second column here and you just square all those answers. Dang, I did it again. 17 is 139.24, 4.84. 29 is... nope, good. 31 is 4.84. Okay. So there we go. That's all that. And then to figure out our standard deviation, which is sigma. So we have sigma is equal to the square root of the sum, so that's sigma notation, x minus the mean squared over n, the number of terms. Alright, so if you take this column and you add all up, you're going to get that right there. So that's a sum. You're just going to add all those terms up. So for this one, by hand, again, I created a Desmos one for you that's probably shared right now. You get 1,605.72 divided by 13 games. So the square root of this is about 11.11. So that's the standard deviation for B. And then the outlier, so if you look at the data, the outlier is 53. Alright, so if you go in there and you're looking with outlier, alright, our mean is 28.8, and then without the outlier, our mean is a little lower. It brings it down to 26.8. All right, so it's good to get rid of those weird data points. And then with the outlier, or sigma, we just calculated is 11.11. But if we take the outlier out of the data and you recalculate everything, so again, just use Desmos to delete the number and it recalculates everything for you. So our sigma becomes 9.22. You see how that drastically decreases from 11. All right, so basically looking at the outlier, it affects the data, usually adversely, so it doesn't help to have those outliers. So sometimes you get rid of that if you're analyzing data.